Is there actually a filament that is truly sustainable, one that biodegrades at the end of its life, leaving nothing behind? I believe this type of material is incredibly important for the 3D printing community. One reason is that we often need support structures to print complex objects. While many are looking into recycling by shredding material and extruding new filament, that process is full of challenges and is not as straightforward as it sounds. Even when it works, it requires an investment that might be fine for a large studio, but for a small creator with only one printer, it is often not economical. That's why I'm so interested in PHA. It is 100% bio-based and biodegradable in almost any condition. But before we dive deeper, let's look at the most popular material in our community, PLA. While PLA is bio-based, it is only truly biodegradable in industrial composting facilities. I think PHA is a far better material in terms of characteristics and sustainability. But what exactly is it? PHA stands for polyhydroxyalkanoate, a family of natural polymers. Unlike traditional plastics made from fossil fuels, PHA is created through a natural fermentation process. We feed microorganisms, like bacteria, natural sugars and oils, and they store PHA inside their cells as an energy reserve, acting almost like bacteria fat. Because it is 100% natural, it is a truly circular material. It is biodegradable in soil, fresh water, and the ocean. I 3D printed this lampshade using PHA material from ColorFab. The printing process isn't as easy as using PLA. The material is sensitive to warping during the print, so using a brim and glue is necessary for good bed adhesion. Another major difference is that there is no need for a heated bed. The bed temperature was set to 0 degrees Celsius. Also, the printing speed is much lower than PLA. To compensate for that slower speed, I used a 0.8mm nozzle for this lampshade. While the process is slightly difficult, I think this material has great potential. It is very tough and can withstand temperatures of over 120 degrees Celsius without deforming. If you want to 3D print this lamp, you can get the files at e-leora.com. The link is in the description. It also comes with a commercial license option. Let me know what you think about PHA and what else you'd like to learn about the 3D printing process.